Hello and welcome again to this week's bulletin of news and engineering information for the radio and television trade. Today, a bird's eye view of aerial maintenance when we take another look at some work which was done at our Caldbeck transmitter. We bring you an update on WYCOMBE television transmitters and news of tests now underway for AM stereo on independent local radio. In transmitter news, we've this week's work affecting existing stations and details of two new television relays, Liddon in Kent and Great Torrington in North Devon. More details later.
Transmitting aerial maintenance is one of those necessities of broadcasting life, which is often very much begrudged by viewers. No one wants long periods of reduced power, and every effort is made to keep disruption to a minimum. But rigorous aerial maintenance has to be done to ensure continued, trouble-free service in hostile environmental conditions, often at great altitudes. Spare a thought for those whose job it is to climb the mast and work in very awkward and uncomfortable conditions. It's time-consuming work. Even changing a mast light takes quite a time. Many of the masts are 900 or 1,000 feet high, and you need a very good head indeed for heights. Standing on top of the aerial cylinder is definitely not recommended for the faint-hearted. But what's involved in replacing or refurbishing a high-powered transmitting aerial system? Jerry Stallard met up with an IBA aerial engineer at Caldbeck.
Well, Pete, can you show me the aerial system?
Yeah, certainly, Jerry. Before we start on the aerial system, I'll just describe that to get the power from the transmitters to the top of the mast, we go through 6-inch coaxial feeders, slightly bigger than the normal household type, you know. And that ends up, this is the connector that goes on top of that coaxial feeder. Fairly large, probably weighs about 60–65 pounds in weight, costs us round about £3,000. So again, slightly different to the connector you plug into the back of the TV set. We've had problems with the original main feeders here. So last year we replaced them with brand new items. Again, the design of those was such that we wouldn't repeat the sort of problems we'd had. This is the old rigid feeder that we've taken out. It's 4-inch in diameter, and if I could just slide that out of here, Jerry, that's the size of the inner to this coaxial feeder. That inner, with 4 channels running up, is probably running near enough 100 degrees centigrade. We are in a situation where we're going from full power during the day, and then it closed down sort of shortly after midnight. Everything shuts down, and this cools down. And what that means is that this thing is expanding and contracting. That's caused problems in that this spring finger fits into another piece of inner. So the gap is changing, and what it's doing is to chip off little bits of the material on the spring finger. They then land on these insulators, and then, because we're working at such a high power, we end up with flashover between the inner and outer. And just one flashover is enough to take us off service. It will actually trip the transmitters. So that has been a problem. To overcome it, what we've done is to go to a much larger size. This is a 6-inch feeder as opposed to a 4-inch feeder. The inner, because it's a larger feeder, is much larger. It will therefore run at a much lower temperature, and the contact area off the spring finger is greatly increased, and we expect now to run with very few problems from this. In fact, we're expecting none now that we've gone to this slightly bigger size.
Once the transmitter power is delivered intact to the top of the mast, an elaborate distribution system divides and feeds the signal to the sets of individual radiating panels forming the aerial itself. There are 2 half aerials working together. Everything is doubled up for reliability.
What I've done here is basically to turn a short panel upside down. I've taken the cover off. This is the point at which we would feed power in, which is then split 2 ways. And it's an insulator there, there, and there. Now these are made of a mixture of mica and PTFE, called fluorescent insulators. What we've discovered in recent years, in fact in recent months really, is that these things absorb moisture. They will normally not conduct at all. They are very good insulators, but when they get slightly damp, there is a tendency for them to sort of arc over and actually burn up. When that happens, the kind of problems we've had is this strip line will actually melt totally away. If that strip line then melts away, it means we get too much reflective power coming down the mast, and the monitoring and protection gear at the bottom that we use to constantly monitor the performance of the aerials will give a trip, and it will say to the transmitters, turn off until somebody can come and isolate this half aerial. We've lost 2 of these panels. One of the biggest problems when you lose a panel is that not only are they 1,000 foot off the ground, they're tucked into the white cylinder at the top of the mast. We're limited in the number of men that can actually get in there to take a panel out. They have to be fairly slim built. I am at the point of really struggling, and I always try to find somebody that's a lot smaller to get in there. So it takes time. We've then got to bring that panel to the ground, we've got to repair the thing and get it back up. So any fault that we get does cause genuine long-term problems. It could take 2 to 3 weeks just to repair this damage. To overcome this problem, the new panels have got PTFE, which we have soaked in water for, in fact, I reckon you could soak them in water for months on end and then shake them dry. They will not conduct. So we've got over that problem of failure on these panels. Overall, I think once we've re-engineered, we've covered nearly everything that can go wrong. We're getting new components for old, we're getting better components for old, and I think into the future we can look forward to possibly normal maintenance once every 7 years and 20 years usable life.
Pete Wall filling us in on the finer points of aerial maintenance. Now to an exciting development in medium wave radio. Stereo radio test transmissions on medium wave began from our Foxhall Heath transmitter near Ipswich on the 28th of June, and this was the first in the UK to use amplitude modulation for stereo. Medium wave services are currently enjoying something of a revival, with many ILR companies offering split programming on their various frequencies. We've been assessing the different ways of achieving AM stereo and have opted for the Sequam system developed by Motorola. Car radios for AM stereo already exist in the United States, Canada and Australia, and early indications suggest that the system is entirely compatible with existing mono equipment. Most current medium wave radios do not take advantage of the 6 kHz audio bandwidth that we transmit. With suitable receivers, AM stereo does appear to offer a worthwhile benefit, with good results inside the main service area of a medium wave transmitter. The Ipswich tests on Radio Orwell are due to continue until at least the end of July, and subject to government approval, AM stereo could be introduced on a number of ILR medium wave services by the end of this year.
NICAM next, and test transmissions consisting of regular programme sound have just begun from the Durris transmitter and dependent relays in northeast Scotland. In the period leading up to official service on the 27th of July, we may have to interrupt the NICAM signal for essential engineering work. Existing mono sound will not be affected. The next stations to start NICAM testing will be Divis in Northern Ireland, Sandy Heath in Bedfordshire and Carradon Hill in Cornwall, all due within the next few weeks.
This week's transmitter news now starting in Lancashire, where ITV and Channel 4 from Winter Hill are continuing on reduced power during aerial replacement work.
All 4 channels from Blackhill in central Scotland are liable to periods of daytime reduced power until Friday in order to complete the new aerial installation.
In Shropshire, all channels from the Wrekin transmitter will be continuously on reduced power until Wednesday week during a BBC aerial overhaul.
And in South Wales, the Ystalyfera and Cwmtwch relays in the Swansea Valley, weather permitting, will be off from 9 until midday on each weekday morning this week for work on the aerial cylinder.
Also in South Wales, the BLACKMILL relay north of Bridgend will be off from 9:30 to 10:30 this morning, as will the KINGTON relay in Herefordshire, both for electrical inspections.
In Buckinghamshire, the ITV and Channel 4 from the High Wycombe relay will be off from 10 until 10:30 this morning for electrical work.
The Limber Hill relay in North Yorkshire serving Eskdale will be liable to reduced power between 9 and 10 AM and 12 noon and 5 PM today, with a break in transmission from 10 AM to midday during aerial work. The same details will apply to the Gisborough-Cleveland relay for tomorrow.
Also tomorrow, all television services from Reigate and Dorking are scheduled to be off the air from 7 AM to 7 PM for aerial cylinder replacement. Radio Mercury on 102.7 will be on reduced power during that period. If the weather is inclement, this work will proceed on the next fine day.
In North Devon, all channels from Huntshaw Cross and its dependent relays will be off between 9:05 and 10:05 tomorrow morning in order to change the mast lights. Again, if the weather is unsuitable, the work will be deferred until Thursday or Friday at the same times.
More IBA electrical inspections will take place at relays in Wales this week, causing transmission breaks between 9:30 and 10:30 tomorrow morning at Britton Ferry near Port Talbot, Corris near Machynlleth, and Garthill and Nuckless near Knighton in Powys, and on Thursday morning at Clydach near Abergavenny, and on Friday morning at Dowlais near Merthyr Tydfil.
In Wensleydale, the BAINBRIDGE relay is scheduled to be off Thursday from 10 AM to midday for BBC mast and aerial work.
Looking ahead to next week, and on Monday, the Buxton and Burbage relays in the Peak District may be interrupted between 9 AM and 1 PM during Electricity Board repairs.
And South Wales Electricity Board work will mean interruptions at Mynydd Machan between 10 and 11:30 on Monday morning, and at Brecon from 2 to 2:30 on Monday afternoon.
Near Sheffield, the Ooty Bridge relay will be off next Monday from 8:30 to 3:30 for work by the Electricity Board.
Finally, in North West Wales, HTV and S4C from LLANDDONA is due to be off the air daily between 5 and 8 in the morning from the 17th to the 23rd of July during aerial work. This will mean no engineering announcements next Tuesday from transmitters on Anglesey and in Gwynedd.
New television relays and the village of Liddon, 4 miles to the northwest of Dover, is now served by signals from a new relay which came on air early last week. Signals from the main station at Dover suffer from severe ghosting in this area, while the alternative, Sudbury, is affected by both adjacent channel and image interference from the Dover transmitter. TVS, the regional ITV service, is on channel 39 with channel 4 on 64. With that wide channel spacing, a Group E aerial is required, vertically polarised. Liddon is now on the air.
And due this week is a new relay for Great Torrington, about 5 miles south of Bideford in North Devon. The 390 people who will benefit from this new station are badly served by Huntshaw Cross due to screening by hills. Channel 4 is on channel 42, with TSW and TVAM on channel 49. The aerial group is B, again with vertical polarisation. That's Great Torrington, due on the air at the end of this week.
And that's all for this week, but do get in touch if you have any technical queries on independent broadcasting. We hope you'll set your VCRs for next Tuesday morning at 5:45. In the meantime, from Mari Nicholson and from me, Bruce Randall, goodbye from Crawley Court.